Hi, let's talk about neural networks in detail. A neural network is made up of vertically stacked components called layers. Each dotted line here represents a layer. Now, a layer can be one of the three types. First is the input layer. Here is an example of input layer. Now, if a layer is of input type, it will accept the data and pass it to the rest of the network. So, this input layer will accept the data and pass it to the rest of the network. Second type of layer is called the hidden layer. Hidden layers are either one or more in number for a neural network. Here, in this case, the number is 1. Hidden layers are the one actually responsible for the excellent performance and complexity of neural networks. They perform multiple functions at the same time, such as data transformation, automatic feature creation, etc. The last type of layer is the output layer. Output layer holds the result or the output of the problem. Raw images get passed to the input layer and we receive an output whether it is an emergency or non-emergency vehicle in the output layer. Now that we know about layers and their function, let's talk in detail about what each of these layers is made up of. A layer consists of small individual units called neurons. A neuron in a neural network can be better understood with the help of biological neurons. An artificial neuron, similar to the biological neuron, receives input from the other neurons, performs some processing and produces an output. For example, here X1 and X2 are inputs to the artificial neuron, Fx represents the processing done on the inputs and Y represents the output of the neuron. Now in real life, we all have heard the phrase fire up those neurons in one or the other form. So does that apply to artificial neurons as well? Actually yes, every neuron has a tendency to fire, but only in certain conditions. For example, if we represent this Fx by an addition, then one neuron may fire when the sum is greater than say 100, while the other neuron may fire when the sum is greater than 10. These certain conditions, which differ neuron to neuron, are called threshold. So for example, if the input x1 to this neuron is let's say 30 and x2 is 0, then this neuron will not fire since the sum 30 is not greater than the threshold. Whereas if the input had remained the same, that is x1 30 and x2 is 0, this neuron would have fired since the sum of 30 is greater than the threshold of 10. Now negative of threshold is called the bias of a neuron. Let's represent this a bit mathematically. So we can represent the firing and the non-firing condition of a neuron using these couple of equations. So for example, if sum of the inputs is greater than the threshold, then the neuron will fire. Otherwise, the neuron will not fire. Let's simplify this equation a little bit and bring the threshold to the left side of the equations. Now, this negative threshold is called bias. If you have come across terms such as X0, W0 in some other machine learning systems, then in most likelihood, they represent the bias of the system. One thing to note is that in artificial neural network, all the neurons in a layer have the same bias. Now that we have a good understanding of bias and how it represents the condition for a neuron to fire, let's move to other aspect of an artificial neuron called weights. So far, even in our calculation, we have assigned equal importance to all the inputs. For example, here x1 has a weight of 1, x2 has a weight of 1 and the bias has a weight of 1. But what if we want to have different weights attached to different inputs? Let's have a look at an example to understand this better. Suppose today is a college party and you have to decide whether you should go to the party or not based on some input conditions such as is the weather good, is the venue near, is your crush coming? That is, if the weather is good, then it will be represented by a value of 1. Otherwise 0. Similarly, if the venue is near, it will be represented by 1, 0. Similarly for whether the crush is coming to the party or not. Now suppose being a college teenager, you absolutely adore your crush and you can go to any lengths to see him or her. So you will definitely go to the party no matter how the weather is or how far the venue is. Then you will want to assign more weight to x3, which represents the crush in comparison to other two inputs. Such a situation can be represented if we assign weights to our inputs such as this. We can assign a weight of 3 to the weather, a weight of 2 to the venue, a weight of 6 to the crush. Now, if the sum of all these three factors, that is weather, venue and crush, is greater than a threshold of 5, then you can decide to go to the party, otherwise not. So for example, we have taken initially the condition where crush is more important than the weather or the venue itself. So let's say for example, as represented here, the weather is bad represented by 0, and the venue is far off 2 represented by 0. But your crush is coming to the party, which is represented by 1. So when you calculate the sum after multiplying the values of x1 with their respective weights, we get a sum of here 0, 0 and 6. Since 6 is greater than the threshold of 5, you will decide to go to the party. Similarly, imagine you are sick today and no matter what, you will not attend the party. Then this situation can be represented by assigning equal weight to weather, venue and crush with the threshold of 4. Now in this case, we are changing the value of the threshold and setting it to a value of 4. So even if the weather is good, the venue is near and your crush is coming, you won't be going to the party since the sum, that is 1 plus 1 plus 1 equal to 3, is less than the threshold value of 4. These W0, W1, W2 and W3 are called the weights of neurons and are different for different neurons. These weights are the one that a neural network has to learn to make good decisions. Now that we know how a neural network combines different inputs using weights, let's move to the last aspect of a neuron called the activation functions. So far what we have been doing is simply adding some weighted inputs and calculating some output. Now this output can range from minus infinity to infinity, and this can be a challenge in many circumstances. Assume we first want to estimate the age of a person from his height, weight and cholesterol level, and then classify the person as old or not based on if the age is greater than 60. Now if you use a neuron in the current form, an age of minus 20 is even possible. Since you know that the range of age according to the current structure of this neuron will range from minus infinity to infinity. So even the age of something as minus 20 is possible. Given this absurd range for age, we can still use our condition to decide whether a person is old or not. For example, if we have set a certain criteria such as a person is old only if the age is greater than 60. So even if the age comes out to be minus 20, we can use this criteria to classify the person as not old. But it would have been much better had the age made much more sense, such as if the output of this neuron, which represents the age, had been in the range of let's say 0 to 120, then it would have been a reasonable and a sensible output. So let's see, for example, how can we solve this problem when the output of a neuron is not in a particular range. So one method to clip the age on the negative side would be to use a function such as max of 0 and x. So for example, anything which is on the negative side of the x-axis gets clipped to 0. Here x-axis represents the actual values and y represents the transformed values. So for any negative values of x's, for example, if we compare this with the original value, this is the original value. So for a positive x, we had a positive y, and for negative x, we had a negative y. Now, if we are to get rid of the negative values, what we can do is use something like max of 0 and x. So anything negative will get clipped to 0. This type of function is called a ReLU function, and these class of functions which transform the combined input are called activation functions. So ReLU in a sense is an activation function. Depending on the type of transformation needed, there can be different kinds of activation functions. Let's have a look at some of the popular activation functions. Sigmoid activation function transform the range of combined inputs to a range between 0 and 1. So for example, if the output is from minus infinite to infinite, which is represented by this x-axis, the sigmoid function will restrict this infinite range to a value between 0 and 1. Whereas tan h restricts it to a range between minus 1 and 1. So tan h looks very similar to the shape of sigmoid, but it restricts the range between minus 1 and 1 in comparison to sigmoid, which restricts to between 0 and 1. Different activation functions perform differently on different data distribution. So sometimes you have to try and check different activation functions and find out which works better for a particular problem. So this was all about activation functions. Let's recap what we have discussed so far. We know that neural network is composed of different type of layers stacked together, and each of these layers is composed of individual units called neurons. Every neuron has three properties. First is bias, second is weight, and third is activation function. Bias is the negative threshold after which you want neuron to fire. So for example, if the threshold of the neuron is say 5, this neuron will fire only if the combined input is greater than the value of 5. Weight is how you define which input is more important to the other. So for example, if there are 3 inputs, you can assign importance to each of these three inputs. So for example, if you want to give more importance to 3, you can give it a value of 3, value of 2 to x2, and value of 1 to x1. So automatically x3 will be more important in comparison to the others. And activation function helps to transform the combined weighted input to a range according to the need at hand. So for example, if you need to restrict your input, which ranges from -infinite to infinite, to a range of, let's say, 0 and 1, so in that case we'll be using a sigmoid activation function. Thank you.